In this one, we want to find a bunch of these values and then graph this thing. So I'm going to start with the vertex. And since this one's in my standard form, to find the vertex, I'm going to do the opposite of b over 2a. The opposite of b is going to give me a 2 times 2a, which is the negative 1/8. And so that gives me 2 over a negative 1/4, which is going to give me a negative 8. So that's, in this case, is going to be my y value, because this is a horizontal parabola. And that's one of the things I should notice right away, because it's x equals and I've got a y squared. So when I do opposite of b over 2a, it gives me the y value. Now I have to plug that y value back in. So I plug it back into my function. And I just simplify a little bit. That's 64 times a negative 1/8 is a negative 8. Plus 16 plus 8 plus 1 is 8 plus 1, which is 9. All right, so I get 9, negative 8. And then the focus, it tells me right on my formula sheet that I'm just going to go ahead and add to the x value here. So I'm going to do h plus 1 over 4a. So h is the 9 plus 1 over 4 times a negative 1/8. So that's 9 plus. When I do this, that gives me a negative 1/2, which is a minus 2 then. So 9 plus a negative 2 is going to give me a 7. And the negative 8 stays the same. The axis of symmetry is going to be y equals the y value from the vertex. The directrix, I do the same thing, except I do h minus the 1 over 4a. H I already know is the 9. 1 over 4a I already know is the negative 2. So that's like adding the opposite. So that's going to give me an 11. So it's x equals 11. Again, these come right off of the formula sheet. And then the LR is the absolute value of 1 over a, which is the negative 1/8. So when I plug that in, it gives me a positive 8. And that gives me the width of this thing. And then we'll talk about domain and range. I'll wait till I graph it, and then we'll discuss the domain and range. So for this one, I plot these ordered pairs. So I've got 9, negative 8. Which is right here. Found it. 7, negative 8, which is right here. That's my focus. X equals 11. It's right here. That's my directrix. It's a dotted line. Y equals negative 8. It kind of skipped that one. Sorry. That's my axis of symmetry. And then the LR is how wide this thing is through the focus. So I would measure up 4 and down 4 to get the width of my parabola here. Okay, that's how wide the parabola is going to be. I also have the x-intercept, if I want to use that as well, which is this point, which I can reflect. So I get a graph that looks like this. Okay? And now in terms of the domain and range, when we talk about the domain, I look at this thing and I see that I have the x values that are less than or equal to the positive 9. And for the range, I see that this thing is slightly increasing and slightly decreasing forever. So the range of this one is going to be all real numbers. Okay? If I look at the next one, I want to graph the circle. I'm going to identify the center. Remember, it's x minus h, so we have to do the opposite of that. That's a negative 4. And it's y minus k, so y minus a positive 1. And then the radius, right here, this is r squared, which means that r value is just a 6. Okay? When we plot the circle, we plot the center. So we've got, let's see, negative 4, 1 is right here. I count 6 in every direction that I can. And now I just draw the best circle that I can. And the graph that's on this paper is probably not super accurate. So my circle is probably going to come out just a little bit oblong, but that's okay. And there's my circle. As long as we put in a good effort and try to make this thing look like a circle. And now domain and range. The domain values, the only x values that are used are from here to here. And so it looks like the domain values that I have start at negative 10 and go all the way up to positive 2. And so an easy way to write that would be to say that negative 10 is less than or equal to x, less than or equal to 2. And I can just express that in terms of a compound inequality, or we could use interval notation. That would be fine also. For the range on this one, it looks like it starts down here and it goes up to this value up here. So it looks like my highest value is a positive 7. My lowest value is a negative 5. So it goes from negative 5 to positive 7. And that's it. Okay. So I've just listed my domain and range just by looking at the graph and seeing which x values and which y values are covered. Okay. If I look at the next one, this is going to be an ellipse because I have a plus sign in between. So for this one, I'm going to find the center first. Just like the circle, I have to take the opposite of each of these things. And keep in mind, you got to be very careful here because this is a vertical ellipse. My y value is listed first. So over here, I've got my k value, and over here, I have my h value. All right, and that k doesn't look anything like a k. Let me try again, so no one has to be confused. And so when I identify the center here, it's actually going to be 1, 3. The major axis, well, I've got a squared is 16, so a equals a 4, so my major axis is 8. B squared is a 4, so b equals a 2, so my minor axis is 4. And now the foci here, I just have to take this right off of my formula sheet. Since this one is vertical, I know that the h value is going to stay the same. The k value is the one that's going to change. I'm going to do k plus or minus c. K is the 3. The c value I'm going to have to take off to the side and find. Remember that c squared equals a squared minus b squared for our ellipse. All right. And so what we have here is I've got a squared, which is 16, minus the 4. So I've got c squared equals 12. I'm going to go ahead and take the square root of each side. And when I do that, I find out that c equals approximately 3.5, or plus or minus 3.5, which is where the plus or minus in our formula comes from. So I do 3 plus the 3.5 gives me a 6.5. And I do 3 minus the 3.5, which gives me a negative 0.5. And now I'm just going to start plotting these values. So I've got 1, 3, which is right here. That's my center. I'll plot my foci next. 1, 6.5 is right here. 1, negative 0.5 is right here. For my major axis, since this is a vertical ellipse, my major axis should run up and down. And I have to count 4 in each direction. It's going to be very close to the foci on this one. My minor axis is going to run horizontally because it always goes the opposite of the major, and I have to count 2 in each direction. And now I just draw the best ellipse that I can draw. I do my best. I try to make it look like an ellipse, and that's it. Okay? In terms of the domain and range, very similar to what we did with the circle. I'll look at the x values that are being used. It starts back at negative 1. It's about to do interval notation. I'll do an inequality again. So back at negative 1, less than or equal to x. But then it stops when I get up to what looks like positive 3. Okay? And then the range, I do the same thing. It looks like that one also starts at negative 1. And it looks like that one goes all the way up to, what is it? 3, 7. Okay, and that's it. Domain and range, we're just looking at which x values and which y values are covered. In this last one, this is a hyperbola, and I can tell because of the minus sign that's in between. Almost everything that's on this is very similar to our ellipse. We've got a little bit more stuff to deal with, but I'm going to start with the center. Right away, again, this one is horizontal because I start with the x value. So then my center is going to be a negative 2, positive 3. Remember, I got to take the opposite of those values, or essentially take the opposite, because there's a minus sign built into the formula. For the vertex on this one, because it's horizontal, it means my y value is not going to change. That's going to remain as a 3. And really, that's going to be the same thing for the foci as well, so I can fill those in ahead of time. And now for my vertices here, it says that I should do h plus or minus my a value, because my transverse axis lands on the vertices, so I'm essentially getting to the endpoints of my transverse axis. So I've got negative 2 plus or minus a, which is a 3 in this case. So I've got negative 2 plus 3, which is a 1, and negative 2 minus 3, which is a negative 5. And then for my foci, it says to do h plus or minus c. And I got to take that off to the side. My c value equals a squared plus b squared this time. Because this is a hyperbola, I essentially use my Pythagorean theorem. So it's going to be c squared equals 9 plus 25. So c squared is going to equal, let's see, a 34. And now I have to take the square root of that, and I'm just going to round it. And typically with these, I always round them to 1 decimal place. It doesn't make much sense to keep it any more than that. It gives me about a 5.8. All right. So now I do the negative 2 plus. Sorry, let me come back over here and write this down. Negative 2 plus or minus the 5.8. So I do negative 2 plus the 5.8, gives me a 3.8. I do negative 2 minus the 5.8, gives me a negative 7.8. And now the transverse axis, my A value this time is 3, so my transverse is 6. My B value this time is 5, so my conjugate is 10. And unlike the major and minor axis, the transverse can be smaller than the conjugate axis. That's just the way it goes. Okay. So for this one, I'm going to go ahead and graph these things. So I've got my center at negative 2, 3, which is right about here. The vertices at 1, 3, right here, and negative 5, 3. So those are my vertices. The foci at 3.3, comma 3. So 3.8, comma 3. And then a negative 7.8, comma 3, around here. And now my transverse and conjugate axis. The transverse axis, because this is horizontal, so my transverse should be horizontal. And really that should already be graphed as I count 3 in each direction. 1, 2, 3. I see that it lands me right here on my vertex. That is the endpoint of my transverse axis. So the transverse axis is already graphed right here with these values, okay, my vertices. Okay, so don't lose track of those vertices in there. The conjugate axis will then run up and down, so I have to count 5 in each direction. I just put a little mark. And now here, just like my ellipse, I've plotted 4 points using my axes, transverse and conjugate this time. Instead of drawing a circular shape, I'm going to draw a box. Okay, this is where I draw my magic box. Again, I do a dotted line for this thing. And I call it my magic box because when I connect the corners of this magic box, it gives me my asymptotes for this thing. Okay, so now I've got these oblique asymptotes. And now to draw my graph, I simply start at the vertex, and I draw a curve that hugs the line. I start at the vertex, and I draw a curve that hugs the line. And that's it. And so these asymptotes kind of give me how wide this thing is going to be. I've got my foci inside each of these, and that's it for that. Okay. So let's talk about the domain and range of this thing. The domain, as I work from left to right, it looks like I've got a bunch of values over this way, and I've got a bunch of values over this way, but I'm missing the values between here and here. So I'm missing the values from negative 5 to positive 1. So if I want to do this as an inequality, I would say that I've got the values that are less than negative 5, or I could also be in the values that are greater than 1. All right, and that would work in terms of a compound inequality that represents my domain here. In terms of the range, as I go up and down on this thing, the range is everything. All the y values are covered, so the range is all real numbers. And that's it. Hope this was helpful, and good luck on your final exam.